All right, you guys, so this is 10.4, and we're going to be using the Pythagorean theorem, and we're going to use it to prove whether something is a right triangle or not. We are also going to use something called the distance formula to help us find the distance between 2 points in the coordinate plane. So, right here, the converse of the Pythagorean theorem is if the equation a squared plus b squared equals c squared is true for the side lengths of a triangle, then the triangle is a right triangle. So what's going to happen is we're going to be given all 3 lengths, and we're going to test to see if it balances out this equation. If it does, it's a right triangle. A common error when using the converse of the Pythagorean theorem, always substitute the longest side in for c, because we're going to assume that that is our hypotenuse, right? Because if it is a right triangle, we would then call it our hypotenuse. So let's look at some examples here. So number 1, it says, tell whether this triangle is a right triangle or not. Now it looks like it is, right? But we can't assume that it is unless we mathematically prove it. So we would look at all these lengths and say, okay, the largest side is 25, so we're going to put 25 squared in on the c value, right? So for when we think about a squared plus b squared equals c squared right here, the longest side goes in for c. And then the other two are, it doesn't matter if you put them for a or b, so I always just put the smaller number in for A, the little bit larger number in for B. And we would test to see if this comes out to be balanced. So we would do 7 squared, which is 49, 24 squared, which is 576, and then you'd have to do 25 squared, which is 25 times 25, and you would get 625. We would then say, okay, let's see if 49 plus 576, and we would see if that equals that 625. It does. So this proves that this is a right triangle. So we'd say this triangle is a right triangle. Boom. And that would be our answer. This is our work behind it. We do the same thing over here. Again, it kind of looks like it is a right angle, but we have to prove it. So our longest side is 90, so that goes in for C. And then we have the 40 squared and the 80 squared in for our A and our B values. We would then do 40 squared, which is 1,600, plus 80 squared, which is 6,400. And see if that equals 90 squared, which 90 squared is 8,100. We would add those two together, and you would end up getting this side to be 8,000. This side is still 8,100. We see that those do not equal, so this is not a right triangle. So it's just proving whether it is a right triangle or not. Now, on one of the worksheets that I'm going to supply for you this week, we're going to go a little bit further even, kind of go into a geometry level and say, okay, since it's not a right triangle, is it acute or is it obtuse? And we're going to look at these two numbers, and that's going to determine whether it's going to be acute or obtuse. But if it's a right triangle, we just write down that it is a right triangle. So on your own, you go to the next page here, and we flip over here, and we would have these on your own. Now they don't give us pictures, but we use the same idea. So I highly encourage you to stop right here and test to see if these side lengths for each one would prove to be a right triangle. So for number 1, 18 is my longest length. So I put 18 squared in for C, and then I put 10 squared plus 15 squared on this side. So 10 squared we know to be 100. 15 squared we know to be 225. And 18 squared we know to be 324. And we would then test that left side. Say, okay, 100 plus 225 is 325 equals 324. That is not true, so this is not a right triangle. And that's our answer. Our work, our proof of it is down here. And then do it one more time. 50 is my largest, so that goes in for C. 30 squared is my A. 40 squared is my B. And we're just seeing this, so this would be 30 squared is going to be 900. 40 squared is 1,600. 50 squared is 2,500. And we would add those together. Those add up to 2,500 equals 2,500. It checks out. So we would say this is a right triangle. So that's just proving whether it is or not. And again, we're going to go a little bit further on one of the worksheets. I'll explain how to do it, of how, okay, if it's not a right triangle, is this obtuse or an acute triangle? Now, we can also use part of the Pythagorean theorem to find the distance between 2 points on the coordinate plane, the diagonal distance here. So it's going to be the second part of this, is the distance formula. It's a formula you can remember. If you don't remember the distance formula, you can always use the Pythagorean theorem and create a right triangle in the coordinate plane like we did in the last lesson. But here is the Pythagorean theorem, the distance formula. If you're given 2 points, like x1, y1, x2, y2, you can find the distance between them. I'm going to write it down here by doing this. The distance equals the square root, it's a big square root, of y2 minus y1 squared plus x2 minus x1 squared. So we would just be substituting numbers in for these 4 values right there, and then eventually getting to our distance between those points. Some people say the distance formula looks like a girl, so if I wrote it over here, just the skeleton of it, you got to use your imagination here, but distance equals, so just this part right here, the skeleton of it looks like a girl. So this is the girl's hair. This is the girl's eyes, right, the parentheses. The girl's pupils right here, the subtraction signs. Her nose is the addition sign there. And you can kind of see the face here. And then her eyelashes, right, the cartoon eyelashes for a girl are the squareds. So you can kind of see that it looks like a girl a little bit. And then you would just put the y2, y1, x2, x1 right there for the numbers. So let's use that. So example 2. Find the distance between 2 points. So we have these 2 points, we label them. This is x1, y1, x2, y2. So we don't even have to plot these, we could just put them into the distance formula and find the distance between them. So you use y2 minus 1, or y2 minus y1 in the beginning. So it'd be the square root of y2 is negative 1 minus y1, which is 5. And then don't forget to square it, plus x2, which is 2, minus x1, which is a negative 3, and we square that. And then we would have to evaluate everything underneath the square root sign first before we take the square root of anything. This square root does not cancel out this squared and this squared, right, because of this addition sign. It would have to be over both of them separately. So we would do negative 1 minus 5, which is negative 6 squared, plus 2 minus negative 3, that turns to addition, and that'd be 5 squared. Oops, the squared is on the outside there. And then negative 6 squared is a positive 36. 5 squared is 25. That's why the squared is within this distance formula, because we want these distances to be positive. You would then add these together. So this would equal 61. And that would be your distance between those 2 points, is the square root of 61. If you can take the square root of if it's a perfect square, then put it down to an integer. If it's not, just leave it like that. So that's using the distance formula. So we can practice that a little bit more here on your own. So again, on the next page, you find the distance between the 2 points. If you're comfortable with it, then just pause the video and just finish out and then just check your answers. Otherwise, you can follow along with me. We have these 3 on your own. So, number 3. x1, y1, x2, y2. We use the distance formula. Square roots of parentheses y2, which is 2, minus y1, which is 4, squared, plus x2 is 5, minus x1 is 0, squared. And then we would eventually just simplify this a little bit more. The square root of 2 minus 4 is negative 2, squared plus 5 minus 0 is 5 squared. So this becomes 4. Negative 2 squared is 4 plus 25. So this ends up being the square roots of 29. And again, that's not a perfect square, so we just have to leave it as that. And that's, again, why we can't count these diagonally. There's no way that we'd be able to count and say, oh, the distance is square root of 29. We have to do the math. So if we do number 4, this is my x1, y1. This is my x2, y2. And I'm putting them into that distance formula. So the square root of y2 minus y1. So y2 is negative 8 minus y1, which is 3, squared, plus x2, which is 4, minus negative 1. And then square that. So this becomes the square root of negative 8 minus 3 is negative 11. What's that? Hold on, let me finish this real fast, okay? Yep, shh, just a second. I'll be there in just a second. So then we do negative 11 squared plus 4 minus a negative 1. That turns to addition. That'd be 5 squared. Then we evaluate it. Negative 11 squared turns to a positive 121 plus 5 squared is 25. And you would then add these two numbers together. It would be square root of 146. And eventually, again, we'll start saying, all right, let's simplify the square root. But right now, let's just get to the distance. Here's the last one. X squared, or x1, y1, x2, y2. Square root of y2, which is 2, minus a negative 6, that was my y1, squared, plus x2 is 6, minus a negative 10, squared. Then I evaluate it. This turns to addition, so this is 8 squared. 2 plus 6 is 8. So this turns to addition as well, so 16, 6 plus 10 is 16 squared. And then we just have to evaluate it. So 64 plus 16 squared is 256. When I add 64 to 256, I get 320. And again, we'll stop there. That is my distance of that. So really just be able to do that. I mean, this example 3, you can try that one. I'm not going to go over that one, so that can just be an example you do where you just kind of find all 3 distances. And then the key here is once you find these 3 distances, like distance 1, distance 2, and distance 3, you would then put them into, so you'd have like a distance for each one of these by using the distance formula, and you would put them into the Pythagorean theorem, the a squared plus b squared equals c squared, to see if your friend made a 90-degree turn right here. So we're seeing what is that angle. Did they make that a 90-degree turn or not? So that's just the distance formula and also the converse of the Pythagorean theorem. We'll do more practice online with this. Again, if you have questions, do not hesitate to email me or chat me up in the Google Classroom. See ya.